Hi, in this video we will learn about so-called one-sided limits, left limit, right limit, and we will see that when such limits are useful to study and how they are related to the actual limits. Well, let me start with the definition of left limit. So in short, left limit means that we are approaching to A only from the left side. It means that the x, the values of x that we put in the table is only for the values that are less than A. And then that's how we get closer and closer to A. But a little bit technical definition would be that we say the limit of f as x approaches to A from the left is equal to L. So this whole wording is written here, is denoted by this piece: limit of f of x, lim of f of x, as x approaches to A. That negative sign there, it means from the left. That means that we are studying the left limit is equal to L if, well, again, like the definition for the limit that we had, if we can make values of f arbitrarily close to L. How? By taking x to be sufficiently close to A with, this is the part which is different, with values less than A. In other words, we are only studying or getting closer to A from the left of A with values of x which are less than A. What does this mean in terms of studying the graph? It means that if there is a graph of function here, if you're studying the left limit, you just ignore the right side of this graph. Just ignore it and look what happens, or find the trend of the values of function as x gets closer to A from the left. So this is how we study the left limit. Well, similarly, I won't write the right limit in complete form. Similarly, the right limit, is defined, and what we have is that we have a different notation for right limit. It means that x approaches to A from the right. That plus sign means from the right as L, and in that case we only study, we get closer to A using values which are greater than A. And as before, if there is a graph of the function, we basically ignore the part which is less than A and just study the trend of the values of f as x gets closer to a from the right. Okay, let's see an example here, which actually is by graph. So example, consider the following graph. And find a limit of f of x as x goes to 1 plus from negative, and a limit of f as x approaches to 1 from the right. What is the function? Well, the graph of the function is this. So this is a 1 here, and then the function has this form. Okay, this one, and then this goes like this, and here's that. Okay, so while you're trying to study that, note that, okay, I am trying to find x approaching to a from the left. A here is actually 1. We already know that. This is 1. So this approaches to 1 from the left. That negative sign means the left. Well, it means that you ignore the graph of the function to the right of this line and just look at this piece. As x gets closer to 1 from the left, while the function has this graph which approaches to 2. So this gives us 2. And if we consider the right part of the graph as x approaches to 1 from the right, while the graph goes down and the values of y gets closer and closer to this value, which is 1. And it's nice to see that also f of 1 is here. It's 0. And you see that each one can have different values. One important remark here is that one-sided limits, right limit or left limit, are specifically useful when the function is piecewise defined. Well, for example, if you have the function absolute value of x as absolute value of x over x as x approaches to 1 minus, or absolute value of x as over x as x approaches to plus. Why I said piecewise defined? Because look, absolute value of x is a piecewise defined function. So for x bigger than equal to 0, it gives us x, less than 0, it gives us that one. And when you have such a thing, such function, well, these were limit as x goes to 0. Such functions, if the point of the limit is the separating part of the domain, that's when this one-sided limits are very important. Why? Because, okay, when I'm approaching to 0 from the left, meaning what? Meaning that all considering values of x which are less than 0, it means that the absolute value of such numbers are going to be given by negative x. And when you have negative, these two cancel and you get negative 1 as x goes to. Well, limit of constant, doesn't matter left, right, you can use the table, you get always the same constant. When it comes to the positive value, we are only considering the values of x which are greater than 0. So in that case, absolute value is given by just x itself. And these cancel, you have the constant 0, constant 1, and the limit is 1. The left limit was negative 1, the right limit was 1. Or, for example, if a function is given like g of x, which is equal to 2x minus 1 for x is bigger than 1, and for x is less than equal to 1, it is just 1. In this case, limit of gx as x goes to 1 plus. 1 plus means what? We are approaching to 1 from the right or from the values bigger than 1. It means that I can use this piece. It means that just ignore the other parts of the definition. And this limit, as you can use the table of values or the graph of the function, you will see it has limit 1. What happens for the left limit, gx, in this case, x approaches to 1 from the left. It means that x has values less than 1, and then we can use this part of the definition. So it will be just limit of constant 1, which gives us 1 again. Well, in this case, we have equal limit, left limit and right limit. Well, all these being said, it's time to say what is the relation between the left and right limit and the limit of the function. So this is a theorem, a fact, which says limit of a function as x goes to a exists and is equal to L if and only if and only if the right limit of the function exists, the left limit exists, and these are the same number L. It means that if someone knows the left limit and right limit, and well, if they are equal, then you can conclude that the function has limit and limit is the same number. And also you can use it the other way around. If the left limit exists and right limit exists, but they are not equal, or one of these one-sided limits does not exist, then you can conclude that the limit does not exist. So let me write this as a note. The above statement can be used in two ways. One is that, well, if someone first finds that limit of f of x as x goes to a plus equals to limit of f of x as x goes to a minus, both of them are equal to L, then you can conclude that, well, the actual limit, not one-sided limit, exists and it's equal to L. This is one, how we use this, one way. The other way would be that if limit of right limit exists and the left limit exist, but they are not equal, or one of these limits does not exist. One of the one-sided limits does not exist. So if they both exist and they're not equal, or one of these does not exist, then you can conclude that limit of f of x, the actual limit as x goes to a, does not exist. And this is the theorem that actually says why, while trying to find limit of piecewise defined functions, you have to go with the left limit, right limit. Because at the end, you can use this fact and determine that the function has limit, or what is the limit of that. So I will go then through the examples we had for this video. First one was the graph. So the first one, the graph function, what was f of x. We found that the limit of f of x as x approaches to 1 from the right is equal to 1, but from the left it was equal to 2. 1 and 2 are not equal, so that means that the limit of f of x, that as x goes to 1, does not exist. Remember, when I'm talking about this function, this is the f of x. The right limit was 1, the left limit was 2, but the value of the we can conclude that the function does not exist, the limit of the function. The other one is the limit of absolute value of x as over x as x goes to 0 from the left. We showed that it is -1, and we showed that the absolute value of x over x as x goes to 0 plus is 1. Since these are not equal, we can conclude that limit of f of x as x goes to 0 does not exist. And the third example is this function g here. We showed that the right limit as x goes to 1, and the right limit of gx as x goes to 1 plus is equal to 1, and limit of gx as x goes to 1 minus is the same number. Then as a result, we can conclude that the actual limit of the function, the gx, not fx, exists as x goes to 1, and it is actually equal to 1. So this is how we will use one-sided limits to determine the value of the limit of a function, specifically if that function is a piecewise defined function.